My name is Mia Elias, and tonight we're going to be discussing Unit F, Concept 10. In this concept, we're going to figure out how to find all zeros of a fourth or fifth degree polynomial. Our function is negative 21x to the fourth minus 17x cubed plus 12x squared plus 23x plus 3. And our first step is to find all possible positive and negative zeros using Descartes' rule of signs. In the first step, we're just going to write down all the signs that we see in the function, which is a negative, negative, positive, positive, and positive. And since we only see one sign change, we can write there that there's only one positive real zero. To find negative zeros, is a little different. All signs for even exponents stay the same, so we can write down those, which is negative, negative, positive, and positive, and positive and positive. But for odd exponents, they're going to change. So in this one, we see that there are a little more. And because there's 3. But we can't just say 3 because we always have to go down by 2. So it's possible negative real zeros are 3 or 1. After that, our second step is to find all rational zeros for each function. And for this, we are going to be using p's over q's. To find the p's and q's, we're going to use the first integer and the last integer. The p's are the multiples of 3. And since there are only 2 multiples, we're going to write, well, actually 4, because we're going to write plus or minus 1 and plus or minus 3. And we're going to do the same for negative 21. The multiples for negative 21 are plus or minus 1, plus or minus 3, plus or minus 7, and plus or minus 21. To get all rational zeros, we have to put all the p's over q's. The result of that are plus or minus 1, plus or minus 3, plus or minus 1 over 3, plus or minus 1 over 7, plus or minus 1 over 21, and lastly, plus or minus 3 over 7. Our third step is the most critical, and it is to find all the zeros. And because I already know that I only have one positive real zero, I'm just going to start with the easiest one and just plug in 1 to use in the synthetic factoring. And with this, we already know that we bring down the negative 21 times 1, negative 21, you add it up, negative 38 minus plus 12 equals negative 26. Negative 26 plus 23 is negative 3. Negative 3 plus 3 equals 0, which gives us a 0, 0. And because I already know that this is one of my zeros, I can just factor and put it off to the side to remind me. Now, for the next one, we already know that there are no more positive real zeros, so we're just going to use a negative real zero. And because I know that I have to have a fraction, I'm just going to start off with negative 1 over 7 and see where that one takes me. So for this one, we're going to bring down negative 21, and I've wrote it down right here. I don't know if you can see it. Okay, so since it's a negative and a negative, it's going to be positive 21 over 7, which equals 3. So negative 38 plus 3 equals negative 35, and I'm going to do the same. Positive 35 over 7 equals 5, so negative 26 plus 5 equals negative 21. Then positive 21 over 7 equals 3, which gives us, yay, another 0 here. And then finally, we can write that one also as a factor. And because we already have a quadratic, we're just going to plug it into the quadratic formula. But before we do, we can factor out a negative 7 to give us negative 7 times 3x squared plus 5x plus 3. And if you know the quadratic formula, you know that we have an a, which is a 3, a b, which is 5, a c, which is 3. Quadratic equation is negative b plus or minus b squared minus 4ac all over 2a. we're just going to plug in all the a, b, and c, which leaves us with negative 5 plus or minus 5 squared minus 4 times 3 times 3 over 2 times 3. As a result, we get negative 5 plus or minus radical negative 11 over 6. But because we have a negative in the radical, we're going to have to take out the I, which gives us a positive radical. But we're not done here, because the last step is to write complete factorization. So in this one, we're just going to go back and first put down the factors that we first got, which is x minus 1 and x plus 1 over 7. Right here. And we're going to put the negative 7 that we got from, where is it? Oh shoot, oh, from right here, I'm sorry. And then we're just going to put it in front to keep us from getting confused. And then we're going to put these into a factor. This is going to be a little more confusing because we still have to simplify and distribute the negative sign. So first, we're going to put them in, which is x minus parentheses negative 5 plus I radical 11 over 6. And then x minus negative 5 plus I radical 11 over 6. So first, we're just going to distribute the negative sign to inside that parentheses, or inside both parentheses. And then, just to make it easier on both of us, we're just going to multiply 6 times the x, so we can just put it all together over the same number. And then, but we also have to get rid of this negative, of this fraction, so we're just going to take the 7 from in front and distribute that, and then our final answer will be negative x minus 1 times 7x plus 1 times 6x plus 5 minus I radical over 6 times 6x plus 5 plus I radical 11 over 6. Thank you for watching, and have a good night.